In this example, we're going to show you how to set up and create toolpaths for cutting parts on a rotary axis on your CNC machine. This is mainly going to be done using the Gadgets drop-down menu and the Wrapping sub-menu here. I'm going to start by showing you how to do the Wrap Job Setup, how to relate the part within the software to the way that your rotary axis is set up on the machine. For instance, which of the linear axis is going to be wrapped around the rotary. Also how to specify things like the diameter of the part you're cutting. We're going to look at the way that you're going to need to select a special type of processor when you come to save the toolpaths. And then we're going to work through a selection of examples that show you how to use some of these other specialty tools in the Wrapping Gadget to lay out vectors for things like fluting and spirals. And then finally, how to create a special type of toolpath that helps you prepare your blank and make it cylindrical. So let's begin by starting a new copy of the software. So to set a rotary job up, you're always going to use the Gadgets drop-down menu from the top of the interface here. So if I click on the word Gadgets, we're going to come down to where it says Wrapping, and then when we come through to the sub-menu here, you can see there are 4 options. We're going to look at these options throughout this presentation, but to start with we need to specify the area, size and orientation of our part that we're going to cut. So we're going to click on the option for Wrapped Job Setup. So in this form, we're going to tell the software everything it needs to know about the size of the part we're using and also the orientation of our wrapping. In effect, which of the linear axis is going to be wrapped around the rotary axis when we post-process the toolpaths. To start with, we tell it the length of the cylinder. I'm going to put in 12 for our example, and the diameter of the cylinder, and I'm going to enter 3. I'm going to tell the software we're working in inches out of the choice of units here. Next, we're going to specify the cylinder orientation. So we can either choose the first option, which is going to take the Y values and wrap them around the X, so the X is going to remain linear and the Y will become rotary, or we can choose the second option that takes the X values and wraps them around the Y axis. So in that case, the Y axis stays linear and the X axis becomes the rotary. Which one of these you choose will depend on the specific setup of your machine. So you should check with the machine tool manufacturer if you're not sure which one of these your rotary axis corresponds to. Next, you're going to choose the origin position of the job. So first the XY origin. In this case, I'll work with the XY origin in the lower left-hand corner. And then secondly, we're going to set the Z origin. We can either choose the cylinder surface, which is like the top of the block for a regular job, or the cylinder axis, which is like the bottom of the block. In this case, that's the middle of our rotary axis. For most setups, you're actually going to find that using the bottom here, the cylinder axis, is the better option. That tends to be a much more constant position on a rotary axis than potentially the surface of your cylinder, because if your cylinder isn't a perfectly round shape, you may set the Z0 and it may not be exactly corresponding to what you thought the thickness of the material was. Whereas if you set it off the center, that should always be constant and therefore generally is going to be more accurate and safer to use. Finally, we choose whether we're doing a simple cylindrical wrap, which is like taking a piece of paper and just rolling it around and joining up 2 of the edges in order to make a round shape. Or we can do a spiral wrap. Spiral wrap is a special kind of setup, more typically used if you've some kind of decoration that you'd like to wrap around the object multiple times. In this case, we're going to do a simple cylindrical wrap, so that's just going to take that Y-axis in our case and just wrap that around and make that the rotary values. So we're going to hit OK. We'll see that the software creates a new job and that's automatically picked up the size information from the settings we entered there. The width, in this case the X-axis, our linear axis, is 12 because that's the length of the cylinder we specified. You can see that in the bottom left hand corner here where it says job dimensions. The height has been defined by the diameter of the cylinder that we chose, which was 3 inches, times pi, which is equal to the circumference of that circle. So effectively, when this length here is wrapped around a circle, then we know that's going to give us a 3-inch diameter cylinder. Finally, the depth of the part, the Z depth, is the equivalent of taking a 1.5 inch thick piece of material and again just rotating that around the center so that the total of that would be 3 inches. So that's how we've specified these values here, and that's been picked up from those numbers that we entered into the Wrap Job Setup gadget. So for the first example, we're just going to create some simple text and show you how we can create a toolpath to cut that into our cylinder. I'm going to come down and choose the option here to draw text within a vector box. If you don't have a vector selected when you click on that, then it will just use the job size as the boundary. So in here we're going to type wrapped rotary text in uppercase. I'm going to choose the Arial True Type font here, and I'm just going to leave the bounding box dimensions as it's picked it up from the job size, margin size normal, no stretch on this, and hit apply, so it'll just size that text for me and fit it within the job with a border around it. Now I'm going to hit close. Next we're ready to calculate a toolpath, so I'm going to come up, click on the icon here to switch to the toolpaths tab. That will minimize the drawing tab, open the toolpaths tab on the right here. Now it's always good practice to check your material setup before you calculate any toolpaths, but we have to remember this has been created in the context of the values that we entered into the Wrap Job Setup. So if we click on set here, we can see thickness of my material 1.5, Z0 set to the bottom of the block. That represents the fact that we've set this in the middle or the center of our cylinder. So you can imagine that 1.5 inch of material being wrapped around the center of the part where our 0 is. XY datum is in the lower left, so that's going to be down to the left hand side of our cylinder, and we'll pick that position obviously on the edge for X0, and then the Y0 will be whatever you want the starting point to be around the rotary or the circumference of the circle of the cylinder. Next we've got our rapid value set here, and the home position needs to be larger because we're working from the bottom of the block than the thickness of the material, so 1.7 is safe. I'm going to hit OK. So we're just going to calculate a simple pocketing toolpath to start with. Let's click on the pocket toolpath icon. I'm going to start on the surface of the material at 0. I'm going to cut down 0.1 of an inch, and we're going to select a small end mill, 1/8 inch end mill, so it fits inside the text. Hit OK. I'm going to use an offset pattern to clear these pockets out. We'll just change the name to pocket text and hit calculate. And there we can see the software has automatically opened up the 3D view to display the toolpath for us and put us over into the preview toolpaths menu. Now we can go ahead and preview this in a regular XYZ view, as you can see on the screen here, and take a look at how that toolpath is going to look when it's machined if it was being machined flat. It is not possible for us to preview this and see the animated toolpath in the virtual piece of material when you're using VCarve Pro. If you're an Aspire user, then you would be able to go ahead and do the preview and then go into the wrapped view to be able to see that as a wrapped object. You would not, as an Aspire user, be able to add colours to the toolpath in the rotary view though. It is limited to just doing it in the original material colour. Here we're effectively using VCarve Pro in this case, so I can preview this as a flat job. I cannot preview it as a rotary job, so what I'm going to do is just hit reset preview, close this, and in order to be able to see this as a wrapped part, I actually need to switch off the colour shaded view. What I'm going to do first is just switch on the toolpath again so we can see the toolpath drawn. I just check the box here. I'm going to come up to view and click on the option here to switch off the colour shaded view. We're going to uncheck it. You can see the background goes white now, and it's just showing me my toolpath. Now to view this in its rotary orientation, I'm going to come up to toolpaths. I'm going to come down to toolpath drawing, and at the bottom of this you can see we've got wrapping off, wrap Y values around X axis, or wrap X values around Y axis. You need to remember which one of these we chose when we did our wrap job setup. In our case, we chose to wrap the Y values around the X axis. So if I click on that option, you can see the software, if we spin the view around, has now wrapped that around a cylinder which represents the part we're actually going to cut when we machine this as a rotary job. There's a couple of things we can do to help ourselves visualize this a little bit better. One you can see is that the rapid moves can get a little confusing. That's the red moves that are showing where the tool's going to go in between each part of the job that it's actually cutting. So sometimes it can be advantageous to switch those off while we're viewing a rotary toolpath. Come up to Toolpaths, click on the drop down menu, go to Toolpath Drawing, and under here we can uncheck Draw Rapid Moves. So that switches those off for the moment. They'll still be there in the toolpath, but it just makes it a little bit easier to see what's happening. The other thing that can help here is if we come up to View and switch on the material block. If we say Draw Material Block from the View menu there, that draws us our piece of material as the cylinder, the size of the cylinder that we specified, and shows us how those toolpaths relate to that cylinder. And we can see that the tool's just going to come down and machine that following the surface of the cylinder, but 0.1 of an inch below it, in order to pocket our text into our cylindrical wrapped part. It's possible to wrap any of the toolpath types that we have in the software here, so we may decide that we don't want to pocket this text and that we'd actually like to V-carve it. So I'm going to take the toolpath we calculated, I'm going to hit the delete icon, I'm going to come up and we'll go back to the 2D view. The vectors are still selected, and when I click on the V-carve icon though, I should get an error. And that's telling me that the software can only calculate toolpaths while the view of our model is effectively flat, while it's in the normal X, Y and Z orientation. So it's asking me, do we want to switch off the wrapped toolpath drawing? So I can go ahead and hit yes. Software will then allow me to go into the toolpath form. We're just going to V-carve this text. I'm going to take the 90-degree V bit we've got selected there, and I'll just change the toolpath name to V-carve text, hit calculate. We can see back in the 3D view now, we've still got the material block drawn. We don't have the shaded view on, so we're not going to preview this. But it is now showing it as a flat toolpath again. If we wanted to look at this as a rotary part, we'd need to come up to Toolpaths, Toolpath Drawing, wrap Y values around X, and there again we can visualize that material block, that cylinder, and see how that V-carving is being wrapped around the cylinder, coming up to the surface and down in order to machine that text. So just to reiterate there, in Aspire it would be possible for us to preview this toolpath and see it in a wrapped situation, so we can actually visualize it as the tool was going to cut it. V-carve Pro, unfortunately we don't have that capability, so we just have to take a look at the visualization that we've got here, and then assuming we're happy with that, we're ready to actually go ahead and save and post-process this toolpath for our CNC. So let's take a look at that. If we close the preview toolpaths form, we would have our toolpath we've got here. I want to output this from my rotary machine, so I'd come up and click on the icon to save the toolpath. Now it's very important in this case that the post processor I choose has rotary capability. It has to be one that's been specially written to do rotary output. It has to understand that you want to take one of these linear axes and actually wrap that around a cylinder rather than output it as linear X or Y values. So in the list here there are some specialty post processors for this. If you have a rotary machine and you're not sure which one of these would apply to you, you could check with the manufacturer, or you could contact Vectric support through the Vectric website. Here we'll come down and choose the rotary post for Mac 2 or Mac 3. It's quite a popular third-party control software. It's important to pick the right one. Here you can see it says Mac 2.3 wrap X to A. A is what typically denotes the rotary axis, so it's saying it's going to wrap the X values if we use that. That isn't correct. We've chosen an orientation that wants to wrap the Y values, so I'm going to come down and choose this option here to wrap Y to A. So we're wrapping the Y values to A being the rotary axis. So I'm going to choose that option there for inches. I'm going to click on the button to save toolpath. And here you can see we get a special screen that pops up when we use a rotary post processor. This is basically just for us to verify what's happening with our model and the way we've set it up, and to make sure all this information is correct before we actually output it. So here again we can see what's happening is this should be wrapping the y-axis, that's right. Diameter of the cylinder is 3 inches, that's correct. And the centre of the cylinder is where we're using to specify our Z0 position. So you may want to just double check these, make sure that this does correspond with your machine, the orientation of your machine, the size of the part you're planning to cut, and how you're planning to set up the Z0. If you're happy with that, you can hit OK. Then the software as normal will give you the option to save the toolpath to post-process it. And if we gave this a name, hit save, that output is what we're going to take to our CNC machine to run on our rotary axis in order to carve that text that we created. In this case, I'm just going to hit cancel here, close the save toolpath menu. And at that point, assuming this job was now complete, we could actually go ahead and save the whole file itself if we wanted to open it up at a later date to edit it. So I'll go up to File, Save As, and in the project folder here, I'm going to call this Rotary and Text. So if you want to, you could take a look at that file, hit Save. I'm going to come up, say File, Close. Now I'm going to set up another rotary job. I'm going to come down to the Gadgets, Wrapping, Wrap Job Setup. I'm going to take the same values that we used before and hit OK to generate a new part with those dimensions and that orientation. And now I'm going to show you another one of the gadget options that we've got. If we come up to Gadgets again, come down to Wrapping, we have the option here to do a fluting layout. And this is just a tool to help automate laying out the vector lines that we need to calculate flutes to go around our cylinder. So if I click on that option, you can see it brings up the form here, and we can specify the number of flutes that we want for our design. So in this case, maybe we'd want to specify 6 flutes. Then we can say how much of a gap do we want our flutes to have from the end of the cylinder. So maybe we'd specify 1 inch and 1 inch here. We also have the option either to leave that as just the lines for the flutes, or to add what in our case will be vertical lines on the part in order to cut coves around it. So we could say create a cove at the start, create a cove at the end. Software will automatically pick up the length and diameter that we specified in the wrap job setup, and also our cylinder orientation. So really these are just for us to double check the values and make sure that they're correct. Once I'm happy with that, I can hit OK, and you can see that all that gadget has done is drawn me a selection of vector lines. These are grouped together, so the 2 lines for the coves are in one group and all the lines for the flutes are in another group. And now we can go across to the toolpath tab and we can use these in order to calculate a different type of wrap toolpath. So in this case, let's take all of our lines. So I'm going to click to select the 2 coves, click to select the lines for the flutes, come over to the profile toolpath, and all we want to do is just machine these flutes down, say, to a depth of 0.2 of an inch from the surface, and we're going to select a large ball nose tool. We're going to select a 1/2 inch ball nose tool to cut these flutes around the part. And hit OK, we'll just take the default values. And very importantly, I want to machine on the vectors. I want the center of the tool to follow each of these vectors to machine my flutes. Don't need to specify any other parameters in here, so I'm going to call this profile flutes, hit calculate. We can see again that the software has drawn this for us in the regular XYZ orientation. At this stage in VCarve Pro or Aspire, we can preview it. There we can check to make sure they look correct. If we're happy with the way they look, then we could go ahead and visualize these in a rotary setup. If we hit reset preview, close, remember you need to come up to view, undraw the color shaded view, so click on that. Make sure the toolpath is switched on so it's drawn. May need to zoom in when we do that. Then we can come up to toolpaths, toolpath drawing. We're wrapping the Y values around the X-axis. You can see that the draw rapid moves is still switched off at this point. If you wanted to reactivate that, we'd need to switch it back on again. I'm going to click wrap Y values. We could go up to view, draw material block, and there we could see how those flutes are going to be cut. So quite simple. Tool's just going to drop in, machine a straight line in order to cut the flutes, and then for the coves it's going to drop in and the job is going to rotate around while the tool is turning in order to cut those coves around the cylinder of our part. So using the gadgets there, we're able to do some of the layout we want for certain types or typical rotary jobs. Let's go ahead and just save this now. Go up to File, Save As. We'll call this Rotary Flutes, and save that in the project folder if you want to look at the way that file's set up. Not going to post-process it, but that would be done in the same way. You'd select the job, hit Save, pick the right post-processor, hit the Save button, and again just check the values before you went ahead and actually gave it a name and saved it, ready to output this file and go and cut these flutes on your CNC. Again, I'm just going to come up to File, Close. Now we'll look at a slightly more complex example now. Let's go to Gadgets, Wrapping, do the same wrapped job setup as before, just taking the same default values, hitting OK. This time though, what I'd like to do is create some lines so that I can effectively spiral around the job. So if we come up to Gadgets, Wrapping and Spiral Layout, just click on that. In here, we're going to set up various parameters, for instance, how many strands we're going to use, the pitch, the offset from the ends. Again, we could add codes to this if we want, and also what kind of twist. And typically for these type of vectors, you're going to set these up so that you can do a barley twist or something like that. Maybe you'd want, again, you might want flutes, but following round in a kind of a spiral fashion around the job. Here, we'll just specify 4 strands. Spiral pitch, in this case we're going to put actually the spacing between these strands, and we'll specify this to be 1 inch. I can start these spirals with a gap between the start and end of the cylinder. So again, let's maybe specify 1/2 inch at the start, 1/2 inch at the end. I'm not going to add coves, and in this case I think I'm going to create a left hand twist. I'm not going to create a right hand twist. We're going to check to create the left hand twist. Check my dimensions and orientation, hit OK. Software will tell me, based on that information I've entered, how many revolutions there are for my spiral, and that could just be useful information I may want to note down. If I hit OK, you can see what this has done is drawn some vectors for me, and if we zoom out, scroll up, we can see that what it's done is kept these lines extended out, and that's because as this spirals around the part, those lines effectively are going to get wrapped around the job. This can be a little tricky to understand, but what you've got to remember as it goes around the spiral is that the top edge here is joining up with the bottom edge. So unlike a normal job where this is the top and the bottom and I couldn't go continuously, it's like I can fall off the top edge and already be at the bottom edge here. So as I go up this line, it's going to come up to here, then effectively it'll be like being at the bottom edge going across, then back down and across, and that's how this is going to continuously spiral around my part. It'll probably be a little more obvious what we're talking about when we get to the toolpaths. So let's go ahead and hit the Switch to Toolpaths tab. Going to select these lines from the 2D view, going to profile these, and I'm just going to take the almost the same values we've got. We'll maybe change it for a slightly smaller ball nose tool. I'm going to go for a 1/4 inch ball nose, machining down to a depth of 0.15 of an inch. Actually we'll go 0.1 of an inch there. Going to machine on the lines, profile, spiral, hit calculate. Now in this case it's not going to be much use for me to preview this because I'm only going to have a small part of it in my preview block. So I'm just going to close the preview menu, come up to view, switch off the color shaded view, go to view and switch on the material block, and then go to toolpaths, toolpath drawing, wrap Y values around X, and now hopefully that's going to make a little bit more sense as to what's happening there. So you should be able to see the start of our 4 strands there. The tool's going to come in to these, and then basically the cylinder is going to rotate in order to move that, what in our case is the Y value, around as the tool moves along in X, and that's what's going to give you that spiral cut. Once more, if we wanted to save that, save the toolpath, make sure we're picking a post-processor that'll do the wrapping or the rotary moves, save, double check the values, and again you've got a file there that's going to cut, in this case, effectively 4 spiral flutes around that cylinder we specified. Once more, if we close this, we could come up to File, go to Save As, and I'll save this one and call it Rotary Spiral. Again, you can open that if you want to take a look at it. To File and Close. Before we finish, I'd like to show you the other option we've got in the Gadgets Wrapping submenu. So you can see we've looked at fluting, spiral, the Wrap Job Setup. Now we want to look at creating a rounding toolpath. We still need to start though by doing the Wrap Job Setup first. So I'm going to click on that option and I'm just going to take the same values that we've been using for the other parts in this video. Hit OK. Then I'm going to come up to Gadgets, Wrapping, and choose the option for Create Rounding Toolpath. The purpose of this is to basically pre-size our blank. So it allows us just to accurately get the blank to be a specific size of cylinder. Now it may be that you just want to machine around or along it to do that so that it's already almost a cylinder, or you may be starting with a square blank and then wanting to machine away the materials in the corners of your square in order to prepare the part for doing the actual rotary toolpaths. So let's imagine that that's the situation we have. Let's say we're starting with a 3-inch square. We're going to do this optimized raster, which will machine the corners away, the corners of our material away. I'm going to say the toolpath name will just take as the default rounding toolpath, and very important, I need to select the tool I want to use to create this toolpath with. So let's click the select button, and in this case I'm going to choose a 1/4 inch end mill tool. I'm just going to take the default values, hit OK, double check the dimensions and orientation, hit the OK button at the bottom of that form there, and if we have a look in the 3D view we can see that what we've created is quite an odd looking toolpath when we look at it in our normal XYZ orientation. Once more, the best way to visualize this is to go up to View, switch off the color shaded view, come down to Draw Material Block, and then go to Toolpaths, Toolpath Drawing, wrap Y values around the X-axis, and now when we look at it, it makes a lot more sense because we can see the cylindrical shape and we can see how these toolpaths have been stacked up so that they'd feature in each corner of the part here and machine that material away in order to leave us with a cylindrical object that we can then use to do the regular rotary machining on. Once more, to output that, we'd go over to the Toolpaths tab, click on the Save option, choose the right post processor, hit Save, and then double check the parameters for it, give that a name, and we could send that across to the CNC. With this type of toolpath, it's extremely important that you get your X0, Y0 position in the right place relative to where the corners of your stock are. Let me just close this for a second. It might be easier to explain this by unwrapping the toolpath again. So I'll go up to Toolpaths, Toolpath Drawing, Wrapping Off. If we look at it in the flat view, we know that our X0, Y0 position is in the lower left hand corner. As we look at this, I can see that that's effectively halfway between these areas of toolpath that are machining away the corners of our square piece of material. So my X0, Y0 is going to be halfway along one of the flat sides of the part. Then what's going to happen is that's going to machine along and then it'll work its way into the corner and around, and everything should line up with the material as it's oriented in the rotary axis itself. If you're not sure about this, then it's probably worth talking to your machine tool vendor. They'll normally have some really good information about the best way to use the rotary axis that they supply with their CNC, how to set it up, how to zero your parts, and other generally useful information about things like tooling and feeds and speeds as well. So in this case, let me go up to File, Save As. We'll save this last file as Rotary Rounding, and again in the project folder there, hit Save. So if you wanted to open that, you can take a look. And before we conclude, let's just take a moment to summarize what we've looked at through this video. Really, the main thing we've been trying to get across is the specialty tools that are available for setting up rotary or wrapped jobs. First of all, it's important when you're doing any kind of rotary job with VCarve Pro or Aspire that you're going to use the gadgets in order to do the wrap job setup so that it knows the orientation of your rotary axis, it gets the size and the diameter and translates those into the correct X and Y values so that when it's wrapped, everything is going to give you the sizes you expected. Once you've matched that setup to your particular machine and the size of job that you're planning to cut, then really it's just a case of creating standard toolpaths in order to generate the part that you want to machine, even though one of those linear axes is being wrapped around the rotary. As we discussed, if you're using VCarve Pro, you can't actually preview those toolpaths. All you can do is do that rotary drawing and see how the toolpaths themselves will be oriented once they're rotated around the cylinder. In Aspire, you could go ahead and preview the toolpaths and then look at that in a rotary orientation. Once you have created a toolpath and you're happy with the way it looks, then you just need to make sure that when you save it that you choose a post-processor that, as always, is appropriate for your machine, but also has that rotary or wrapping capability built into it. If it doesn't, then you'll see an error and it'll tell you that you're basically trying to save a rotary toolpath without using a rotary post-processor. The other options we looked at in the example under the gadgets and wrapping were how to use this to help you lay out the vectors for doing fluting around a cylinder, how to use this to help you lay out the vectors to do spirals around a cylinder for something like a barley twist, say, with a round over bit, or, as we looked at the end there, how to create a special type of toolpath that'll help you to create that cylindrical stock in the first place. That concludes this tutorial.